All right, hello everybody. My name is Cameron. Today I'm going to be going over the programming assignment 1 for Professor Rincon and just going over the theory and stuff like that. I'm not going to be going over any code because that's up for y'all to do, but I'm just going to be going over the theory and basically understanding what you need to do and try to get you started, okay? So if we go ahead and we start reading the problem, we see that him and I are working on our research on compressing an algorithm based on symbol positions. Okay, this is Dr. Rincon's original paper he wrote on the compression. This is nice to kind of understand what you're doing, but it's not required for the assignment. This is something that you can read to kind of get a relative general idea of what's going on, but this is not super relevant to the actual programming you need to do because of we're using different methods. Okay, so we don't have to worry about that. You do have to look into alias gamma and alias delta, which I will go over here in a minute. Okay. So for this, I'm also not going to go over the multi-threading. I don't think I need to. Rincon's going to go over that with y'all. And again, I'm not going to go over anything coding related, just understanding what we need to do. Okay. So let's go ahead and start. If we read it, we're going to need to compute the number of bits needed to represent the positions and the difference between positions for each symbol in the original message using alias gamma and alias delta encoding. Okay, so it's a multi-line input, and it's going to give you the original message, and then it's going to give you n lines representing the symbols, and they're going to be sorted in descending order based on the frequency. Okay, and frequency means how often they exist in the string. Okay, so because there's like 7 A's, then we're going to give you A first, and because there's 7 D's, we're going to give you D second. And I think there's 5 C's or 6 C's. So yeah, we're going to give you C next, and 5, and then 4, and so on. Okay. So you don't have to worry about that. You don't have to worry about the order. You just do the order in which we give it to you, which is pretty nice. So let's go ahead and start. If we have our main string that's going to be taken in, I would recommend saving that somehow. Now, you can't use global variables, so what I would do is I would recommend passing... I would recommend making a structure. Okay, so I'm just going to represent that as like a box. And it's going to have all the data. It's going to have the current message. So the current message. Okay. And then it's probably going to have your positions as an array. Okay. And then it's going to have the difference in positions as an array. It's going to have the symbol that you're currently working on to represent. And it's probably going to have your frequency, which is an integer, okay? So, and then you'll have all these things here as well, but we'll worry about that in a second, okay? So I would have a little structure here that keeps track of all that. That way it's going to make things nice and concise for you. And as for implementation, well, what I would do is I would just create a for loop. So I would pass in this message. I would create a structure for A, and I would for loop all of this, and I would say, okay, how many A's are in here? There's 1, 2, 3, 4, 5, 6, 7. So we have 7 A's, so we can keep that as part of our frequency here. We have our symbol, which is A, which we got from this input. And as we're looping through, I would just say whatever position you're on, just add that position to your position index here, because then you can just save, right? And then you can just print these out, right? And then I would do, yeah, that's all you have to do, really. I would say also as you're looping through, make sure you remove so that your new message is going to look like this. So make sure you're removing all the A's as you're looping through. So you're looping through, saving the position of where an A is at, and then removing it, okay? Now, all you have to do for this case is, for the difference in positions, is simply subtract the numbers of the positions. So we have 12 minus 11 is 1, 11 minus 10 is 1, 10 minus 4 is 6, 4 minus 3 is 1, and so on and so on and so on, right? Very, very simple. Just subtract it in reverse order. Excuse me, okay? So there you go. Now, to represent the positions in alias gamma, we're going to have to look at alias gamma real quick. But before we do that, let's go ahead and look at this input here real quick. We see for the second symbol, we have D, right? And you can see that our brand new string does not include any A's. So this is a brand new string with no A's that we are going to be using to count for D. So you'll see that D is going to be right here in the 12, 13, 14, 15, 16, 20, and 21st position. Okay, so make sure you are not counting where D is at in the original message, because otherwise these numbers are going to be wrong, right? Yeah, and then it's going to be the same thing. So just subtract 21 minus 20, which is 1, 20 minus 16, 4, so on and so on. So it's very, very easy for that. And again, you want to, I would recommend you save these in a structure. Again, you don't have to, but, you can't use global variables. And I think passing a message after removing it and saving all the data between each symbol is going to be pretty efficient. So yeah. And then it's just that, so on and so forth, right? So now we do that for C, and then we do that for B, and then we do that for E, okay? Very simple. So now what we need to do is represent the number of bits in the position. Because you got to remember, every time a string is taking up, a character is taking up a string, a place in the string, then that's going to cost bits for the computer, right? And the way we calculate the bits is actually by doing alias gamma in this case. So what we can do is we can take the number of bits to represent positions. So these are going to be additive. So we take 1, and we can go to our alias gamma, and we can read about this. So we have n equaling to the floor of the log base 2 of x, right? And x in our case is going to be the 1 and the 2 and the 3 and the 4 and the 10, 11, and 12. Okay, that's what your x is going to be for this part. And then your x is going to be these for this difference here, right? So when we look at here, we can represent these as numbers. Now, for Rincon and I's research, we have to dive deeper into what these numbers actually mean. So we have like the 0 here, which represents it represents like the power that this is going to. So we have like 1, and then we have 0, which is 0 here, and then we have 0, which means that this is power to 1 again, because this is in binary, and then we have a 1 to add 1, and so on and so forth. So you'll see here we have 2 to the power 2 plus 1. We have 2 zeros, so that's what goes there. And then we have a 1 here to represent that we are no longer worrying about the power, and then we have 1 represented in binary to represent the plus 1, right? And just so on like that, okay? Now, you guys actually, fortunately, I don't think you have to do anything like this. You guys are lucky for that, because that was definitely an idea we had here. But no, all you really have to worry about is the alias gamma of 2 floor log base 2 of x plus 1, okay? Don't worry about this. I mean, this is n for some n here, but you just have to worry about this. This is going to be your main formula, okay, for x. All right. So you're going to loop through all of your positions and differences in positions, and then you're going to input that with your alias gamma representation of 2 floor log base 2 of x plus 1. And when you do all of that, alias gamma is going to give you a number, and you can add all those numbers together, and you'll get 33, okay? So yeah, and then you'll do the same thing for the difference for right here for alias gamma. And then when it's time for alias delta, it's literally the exact same thing, except you're using this formula instead, okay? So alias delta, in case you care or are wondering, is worse for compressing shorter numbers. So you'll see here the bits are 4 bits to represent 1, two, but when you get further down, like into way higher numbers, it uses less bits to represent higher numbers than alias gamma, okay? So in an ideal world, you would use alias gamma to represent small numbers, and then use swap to alias delta to represent big numbers, which is kind of what we're doing for our research. But yeah, so basically, once you've done that for each of the symbols, then down here, you just add all of your total positions for alias gamma. So 7 plus 17 plus 30 plus 55 plus 33, and you'll get 142. Do the same thing for the difference, and then you'll do positions and differences for alias delta, okay? That should be it. I mean, there's really no other way to explain it. Use a structure. Make sure you're using these formulas for the calculations. Yeah, save all the information as you need, and you'll be good to go. So hope you guys enjoyed. Make sure to hit that like button. I'm just kidding. But yeah, perfect. Thank you guys for watching, and if you have any questions, feel free to ping me in the Discord or send me an email or message me on Teams, and I'll get back to you. So, all right, thanks. Bye.